In this video I will show you how to scroll from one screen to another when creating a Zelda-like game in a 2D engine. This has been one of the most frequent asked questions after my last video about top-down movement. And as we are going to see, this seemingly simple question reveals a vast chasm of hidden underlying assumptions, which is also why I think a lot of people struggle with this. So let us take a look at how the original Link's Awakening dealt with this problem, and let us come up with a solution that fits the engine of our choice, which in this case is gonna be Pico-8. I am Christian, this is LazyDev's Academy, let's get started. Yes, this is true indeed. After my last video, the most frequent request was to cover how to make transitions from one screen to another. And this is to me fascinating because the actual transition is actually trivially easy. We're gonna see that in a second. So what I think is happening here is that a simple question is covering a much more difficult, underlying, unaddressed, unrecognized question. It's kind of like asking, how much helium would I have to inhale to offset my own weight? And there's like a simple answer, 1,000 liters offsets 1 kilogram, but let's talk. So first, let us discuss what we're even trying to achieve. So perhaps one of the most defining features of an action-adventure game like Zelda is that there is like a huge world that we can walk around in and have adventures in. And Zelda Link's Awakening is not an exception here. It features an overworld that consists of 256 individual screens. And it always shows you just one of those screens. When our protagonists, yes, it says Zelda on here, but it's not actually Zelda, he's called, of course, Pipi. When Pipi touches the edge of the screen, a short transition sequence starts, where the camera, so to speak, scrolls one screen over. And then the game continues on that new screen that the camera scrolls to. Now, not all top-down games work like this. For example, in a recent video I covered Pokemon Gen 1, which has a very fancy, continuously scrolling map. And other Zelda games work differently too. For example, A Link to the Past has a mixture of both continuously scrolling maps, but also those edges where you get a transition to a new screen. So the screen-by-screen approach feels a little bit more retro, and the modern Link's Awakening remake abandoned it for a more continuous approach. But personally, I prefer it like this. I like how each individual screen is kind of like its own vignette. It's a little picture that you paint. And also, I like how it turns the entire world into like this huge puzzle that you assemble in your head. You see this technique being used all the way back in the original Zelda on the NES. And also my all-time favorite Game Boy action-adventure game, Final Fantasy Adventure, also known as Mystic Quest, works like this as well. Now, as we're gonna see, replicating this scrolling is not really the issue. The problem lies somewhere else. For this video, I will be working with a retro engine Pico-8. And if we want to recreate Link's Awakening, we will bump against a whole lot of fundamental issues. First, there is the question of resolution. The Game Boy screen is 160 x 144 pixels in size. This is both taller and wider than Pico-8's 128 x 128. But in Link's Awakening, the bottom 16 pixels are used up by the small strip of UI, which brings the height of the actual map down to 128 pixels. So each little map ends up being the same height as a Pico-8 screen, but it is still 4 tiles wider. And this little fact already shoots down any attempt to recreate Link's Awakening screens in Pico-8. We just don't have the screen space. All we can do is to pivot to the next best thing, which is to create a map that is inspired by Link's Awakening, which is similar to Link's Awakening. Next up, how big of a map can we actually create? Again, we hit another limitation here, and this one is even more crushing. If we want to use the Pico-8 map system that is built in, the biggest possible map we can have is just 8 screens wide and 4 screens tall, at best. Yeah, that's just 32 screens in total as opposed to 256. That's just an eighth of Link's Awakening. Oof! Yikes! But how is that possible, you might ask? Didn't I just post a video where I recreated all of Kanto in Pico-8? That's true, but of course there's a major difference. In the Pokemon video, I used a custom map management system to import and handle all of the map data. If you cook up your own systems and tool chains, you can get a lot more out of Pico-8. And if you want to see another example of how this looks like, I recommend the Advanced Shmup tutorial series. But that's like 100 episodes. That's quite a rabbit hole. If we attempted this here, this video would spin up to its own series. Remember how this video is supposed to be about Oh, it's about scrolling. So, to prevent things spiraling out of control, I want to use the built-in systems that are available to us in Pico-8 by default. Which means, for better or worse, we cannot create anything close to the size of Koholint Island from Zelda. But that doesn't mean everything is lost. That's still plenty of room for activities. And at the end of the video, I will show you a technique you can use to create bigger maps in Pico-8 after all. And then finally, let's talk about the tile map. Once again, in my Kanto video, I was able to just use the tile map from the original Game Boy game. Pokemon Gen 1 uses just one quite compact tile map for the entire overworld. No such luck in Link's Awakening. A short glance at Koholint Island reveals a mind-blowing variety of different tiles and graphics. Not only does Link's Awakening use different tile maps for different areas of the game, but also each tile map itself is so much larger. In fact, Link's Awakening uses some really sophisticated, cool tricks to make seamless transition between different tile maps, and let me do a quick deep dive on this because this is fascinating. Link's Awakening tile maps consist of multiple parts. One part covers some universal tiles that can be used in every area of the map. Another part of the tile map is reserved for special tiles that only appear in certain parts of the world, like the creepy trees in Tabal Wasteland or the palm trees in Toronbo Shores. These special tiles can be swapped in and out when transitioning from one screen to another, but doing so might scramble up the tiles that are visible on the screen during the transition. So, the developers built the map to have these transition areas. And they have been marked on this map with a green color. Those areas deliberately use only tiles from the universal part of the tile set, so switching out the special tiles during scrolling doesn't mess them up. They serve as a sort of an airlock to seamlessly swap out the special part of the tile map. But it doesn't stop there. The developers carefully designed the overworld in such a way that certain paths are physically impossible, and this allows them to put areas with special tile maps closer together and cram more variety into Koholint Island. So, for example, Mabe Village and the entrance to Tail Cave are directly adjacent to another, and they both use their own special tile map. But even though they're directly adjacent, a row of trees is preventing you from going directly from Mabe Village to Tail Cave. Instead, the terrain is set up in such a way that you have to circle around and pass through a transition area. And think about this, the developers had to plan way ahead to make this happen. Even before the first tiles and maps were created, they would have had already planned ahead, where each area would be, what would be in it, and how they would be connected. The entire world of Link's Awakening is carefully structured from the ground up with the limitations of this system in mind. And as a player, you'd never notice this. It just works seamlessly. Now, there is a lot more to this, and if you want to know more details, I will link an excellent blog post by the Link's Awakening Disassembly Project blog. But for now, let us just keep this in mind as we struggle with our own limitations. Speaking of which, we don't have the screen space, we don't have the space for the map, and we don't have the space for the tile map either. A lot of these are difficult problems, and all of these are just showstoppers if we want to create an authentic recreation of Zelda Link's Awakening in Pico-8. But I think very few of us actually want to have an authentic recreation. I think most of us just want to have something like Zelda, and I think this is still possible. We just have to make smart compromises, plan around those limitations, and we need to lower our expectations when it comes to scope. It is hard to make big games in Pico-8, and that's by design. That's a good thing. So, finally, let us get back to the original question, how do we scroll from one screen to another? Let us set up a small test environment. Let us set up 4 screens that we can scroll between. In order to do that, we need a tile map, and as I said, we can't lift a tile map directly from Zelda, but we can get close. I found this tile map from the LADX disassembly on GitHub. This is actually the universal part of the sprite sheet I was talking about earlier. This covers a lot of the tiles that we need, but since some of the really important tiles are missing, I went ahead and did a manual pass on the tileset and arrived at something like this. And while I was at it, I also rearranged some of the tiles so it's clearer how they fit together. And I marked every tile that looks like PP should be able to walk on top of it with a red flag, flag number 0. In our prototypes, this indicates whether the player collides with it or not. And just like that, I was able to create 4 test screens using the built-in Pico-8 map editor. The screens are somewhat inspired by the top left corner of Link's Awakening's map, is the area west of the Goponga swamp. Now let us start implementing the scrolling. The key here is just to move the entire map instead of moving our character. Let me show you what I mean. So remember how in the last video we made 4 different prototypes in increasing levels of difficulty? I am going to load up my most favorite version, which is this one. It's Zelda 2, the second version, where a PP is moving always locked to the tile grid. This makes collision detection so much easier and is a good starting point for our experiments. Now I'm just going to copy over the map and the tile set that we just created. This is easily done in a text editor. At the end of each Pico-8 file there's like this gibberish, all these numbers. This is the map, these are the graphics and everything else. We can just copy them over from one file and we can paste it in another, and that brings over the map and the graphics and everything else. And we can load this up again, and boom, here we are walking around in our test environment. Now we want to scroll from one screen to another. So in this prototype, the first thing we do every single frame is to draw the map to the screen using this function, this map function. And by default, this map function will draw the map with the top left corner of the map aligned with the top left corner of the screen. But this function actually accepts a lot of parameters that let you specify exactly where the top left corner of the map goes. And we can just use this to scroll the map. So what we're interested in are parameters 3 and 4, S, X, and SY. These specify where the top left corner goes. If we simply plug in the coordinates of the player in the third and fourth parameter of the map function, we can simply move the map with the cursor keys. And this just works. And sure, this looks a little bit goofy because the map starts, where the player is in the center of the screen. And also we're walking backwards. That's a little bit odd. And that's because this is a bit of a logic thing. The map needs to be scrolling in the opposite direction that we're moving in. Think of this like a treadmill. When you're moving forward, the tape on the treadmill has to go backwards. And both of these are an easy fix. Simply take the center of the screen, 64 and 64, and subtract the player position from that. And look at that, this looks pretty good. But also we kind of overshot our target here because this is kind of like what we had in Pokemon, where the screen is continuously scrolling. What we want to have is like the individual screens that we have in Link's Awakening. So now we want to sometimes move the player and sometimes move the map, which means we need to keep track of the position where the map is. And we can do that with a set of variables. I'm going to call them map X and map Y. And now we can use those two variables to draw the map at that location. I added the minus here to account for the treadmill thing that I just talked about. And also I restored the original player movement. Okay, so now we're back to how things were before. Now let us set up a system that scrolls the screen. And we are going to set up a so-called state machine. Again, this sounds fancy, this sounds complicated, but we're already using one right here. State machine just means that the game operates in different modes. Currently, we have a mode called idle that just does nothing, just listens to player inputs. We have a whole function for this called check butts. And then there's a second mode called move. This moves the player using the move player function. So now we're just going to create a third mode called scroll, in which we'll call a new function called move map. And the contents of the move map function is really just the same thing that we're doing when we're doing move player, but instead of changing the player's position, we're just going to change the position of the map. We can get rid of the animation stuff because we're not doing animation this time around, and then we're just going to keep track of how long we have scrolled using the dist variable, and when that reaches 0, we just switch back to idle mode. All we have to do now is just to switch to the scroll mode when we hit the edge of the screen. And this is where we're deviating slightly from the original Zelda game. You see, there's some nuances in which Zelda does things which introduce some wrinkles to the proceedings. I will talk about this in a second, but for now I'm going to use a different game as my template, which is Final Fantasy Adventure, also known as Mystic Quest. This game actually has exactly that kind of tile-based movement that we have here, so it's actually a much better fit. And if you watch closely, you will see that in this game, the player character can actually walk off the edge of the screen by one tile. The map scroll is only triggered if you attempt to leave the screen entirely. So let us recreate this. Let us make the screen scroll when you try to walk off the right edge of the screen. Over in checkbots, we have this if statement here that checks if a tile is walkable or not, and if it is walkable, we just do the movement. We can jump in here and do a little if statement, a little check if we are about to walk off the edge of the screen. If so, we just set the mode to scroll and start scrolling the map. And if not, we just walk normally like before. Oops, this equal needs to be a double equal. And so yeah, this works. This kind of works. So currently it looks as if PP is sliding off the screen, but actually the problem is that they're not moving, right? That they're staying right where they are on the screen. They should be moving with the map. Well, that's an easy fix. We can simply go to the move map function, and we can copy these lines and simply move the player position together with the map. Something to keep in mind is that we need to change this plus into minus because of this treadmill issue that I already discussed. We're gonna run this, we're gonna walk, and yeah, this works exactly as expected. All right, so let us now increase the speed. This is a bit slow. In Zelda and in Final Fantasy Adventure, the map scrolls around the speed of 4 pixels per frame. So let's do something like PSX multiplied by 4. PSY multiplied by 4. And then since we are scrolling faster, we need to scroll for a short amount of time. So instead of 128 frames, we need to scroll for just 32 frames. Let's run this and look at that. Hey, that looks sick. Now, there's multiple problems. We cannot walk back. But also, when you want to go forward, there's like an invisible wall here. We cannot enter the screen. What is going on? Well, that's because our collision detection doesn't actually keep up with the scrolling. Yes, we show the map at a different place. We show different images on the screen. But our collision detection still thinks that we're back on the first screen. Luckily, that is an easy fix. We just need to go to this function. This is this walkable function, and we need to do small modifications. We simply need to add the map scroll to the player's position. That is all that is required. And look at that, we can enter the screen and we can walk around in this new screen, and the collision detection works out flawlessly. Isn't this beautiful? So let us expand this to cover all of the different directions. So I'm just going to expand our if statement to cover the 3 remaining edges of the screen. And that is it. That's all that was needed to just walk around everywhere. We can just walk among our 4 screens back and forth. Isn't this beautiful? Isn't this beautiful? But of course, if we walk off map, crazy things happen. Yay! So yes, we have successfully implemented Final Fantasy Adventure style scrolling. Now, this wasn't that hard, was it?
I could do this all day.
Now yes, this is not entirely how movement and scrolling in Zelda works. As we discussed in the previous video, real Zelda-like movement is pixel perfect, but now also the scrolling works slightly different. If we watch a recording frame by frame, we will see that the scrolling in Zelda starts much earlier, as soon as PP Sprite even touches the edge of the screen. And then during the scrolling, PP Sprite will slowly move onto the new screen. This is to ensure that our character won't be left standing off screen when the scrolling is over. So let us begin by moving our test environment, our test screens, onto the 4th and final prototype from our previous video where we had pixel precise movement. And now let us load this up. This was called Zelda 4. We run this and this looks nice, but some things don't look quite right. What is going on here? As you can see with this edge, there's just a little bit too much overlap happening. This looks wrong. This doesn't look the way it's supposed to look. Well, it turns out the issue is with diagonal movement. When we walk orthogonally, this works fine, this looks correct. But once we walk diagonally against this edge, we simply get this additional overlap that looks wrong. Now, this is something that we worked a little bit on the previous video. This kind of overlap is something that we wanted to have sometimes in some cases, but it shouldn't be happening as easily as it happens now. And this happens because when we walk diagonally, we are using collision boxes meant for orthogonal movement. Let me quickly bring back the visualization for the collision points to see what I mean. In the draw function, we put in this little loop that shows us the collision points. You see those white dots, right? And now you can see that the white dots prevent us from walking into the wall, but when we walk downwards and diagonally, we're able to scooch a little bit into the wall, which is bad. That's not supposed to happen. This set of dots, this collision box, is meant for downwards movement only, and for diagonal movement, we need a new set of dots. Oh, and by the way, there's like an animation happening in the top left corner. That's because we had this flower animation, and that doesn't work with the new tileset that we have here, so sadly we have to remove this. Now back to collision boxes. The current collision boxes are here, and there's two ways of solving this problem. There's a quick and dirty patch, and there's a beautiful, from the ground up solution. And since this video is supposed to be about scrolling, yes, scrolling, we kind of want to avoid recreating our movement system from the ground up for now. Let us do the quick and dirty patch. And then later on I will give you some resources you can use to build a new system from the ground up if you want to. So let me just add 4 more tables, and these should be the collision boxes for the diagonal movement. And yes, technically they're not boxes, they're just a set of points. And indeed there's a bit of a difference here. Previously our list consisted of 4 numbers. So that was 2 points. Each point would be described by 2 numbers, 2 coordinates. But now the diagonal collision boxes consist of 6 numbers because we have 3 points now. This also means that we need to also modify our check move function that is there to process these points. Previously, this function expected just 2 points to be in each list, but now this function needs to be working sometimes with 2 points, sometimes with 3 points. We had a hard-coded solution here, but now I have this loop here that deals with whatever lists we throw at it. And then we need to pick the right collision box depending on which direction we're moving. And this is where things get really, really messy. Currently, we have those beautiful 4 neat if statements, each for every movement direction. You see they all respond to button presses. We don't really have a special check for diagonal movement. We just allow multiple of those if statements to trigger at the same time in each frame, and then the velocity gets added, and sometimes, the animation gets overridden with the other if statement depending on the order in which they trigger. So yeah, we don't have a bespoke check for diagonal movement. I need sensitive audience to avert their eyes now because we're going to implement diagonal checks in the dumbest way possible. We just add 4 more if statements, and we want to actually link all of the 8 statements that we have together into a huge else if block. So each frame only one of those if statements triggers. We now have a bespoke if check for every combination of buttons. And we also want to check the diagonal first, so the orthogonal movements don't override the diagonals. The order here matters. And that allows us to set the new diagonal collision boxes for the diagonal movement now. And finally, we're gonna do something strange here. For the diagonal movements, we are not actually setting the animation. That is right. If you press 2 buttons at the same time, people will continue facing whichever direction they were facing, but possibly move in a completely different direction. Now this sounds like a bad idea. This sounds like it would lead to all sorts of janky behavior. And indeed, if you now press a diagonal movement from a standing position, you will see this kind of like crazy moonwalk. But here's the thing. That's actually authentic behavior. Yes, it's crazy, but it's true. As QuietFox157 pointed out in the comments section last time around, this is actually how Link's Awakening works. And the speculation here is that maybe this is set up so you can adjust your aim while you're walking, so you can aim your bow or your boomerang better. And I think that's a plausible explanation. And sure, this might sometimes cause some funky behavior. Sometimes you might end up walking backwards. But it's also just so elegant and simple. We simply are not changing animation when walking diagonally. If it's good enough for a commercial Nintendo game, it's sure good enough for us. And yes, this is incredibly verbose and incredibly inefficient. But hey, there is a tidbit of optimization that we can do here. You know how at the end here there's a little bit here where we're doing normalization, where we make sure that when walking diagonally, we're not walking any faster. Well, now we can just remove this and we can do our normalization right here in the actual if statements. That's kind of efficient. That's some sort of efficiency, right? Right? Please clap. And so yeah, this makes diagonal collision detection work a lot more natural now. We don't get this overlap. Now, just to clarify, the reason why this is so incredibly inefficient is that because we have, all those if statements, and all those if statements do is just to set the same set of variables to just different values. What we should do is we should be setting those variables only once, and we should maybe get the correct values that should be in those variables from maybe something like a table. Now, in order to do that, we need to kind of like convert the button presses into a single number that indicates which direction we're going to. And then we can use this number to fetch the right value for those variables from a table. And I just don't want to get into the weeds of doing this right now because it works, it's fine. It's just a little bit verbose. I'm going to leave this as a bit of a challenge for you optimization freaks out there, but if you want to see how this works, I recommend, once again, the advanced shmup tutorial where I implemented the movement exactly like I just described. And hey, it's not that bad, it's just the second worst piece of code that you will see in this video. Now let us get back to where were we again? Right, scrolling. So even though this is a different prototype, the scrolling works exactly according to the same principles. We set up a variable to track the position of the map. We then draw the map based on those variables, and also we make sure that the collision detection takes the scrolling of the map into account. We now set up the scrolling mode, which is an extra step here because in this version of the prototype we actually didn't have a state machine in the first place. And now we can simply copy over the move map function from our other prototype. That's the same thing. So far so good, nothing broke, it all still works, but now we need to activate the scrolling mode. We can jump in here and use the same if statements that we have in the previous prototype to simply trigger the scroll mode. Now this prototype that doesn't actually have variables that are called new x and new y, so I just included this little patch here that calculates those variables for us. So we save this and we run this, and initially this works alright. It just works straight out of the box. Hey, it's very easy, it's so easy, but then, oh no, we walk diagonally and everything is wrong. Yeah, because the problem is that if you walk diagonally, the map will also just scroll diagonally. It just takes the speed or the current velocity of the player and just turns that into the scrolling. Forgive me, Lord. It's time to go back to the old me. That's right, we just add a whole bunch of additional if statements. And this time with even more jank because we're basically just repeating the same if statement twice. It's kind of an awkward spot that we're in here right now because either we repeat the if statement or we repeat setting the variables. It's a lose-lose scenario right here. So let's just leave it like this and just never speak of this again. Because the upside is that it actually works. It works wonderfully. Look, we can walk diagonally and it's fine, it scrolls correctly. But wait, as I said, this is not exactly Zelda scrolling. This is still the Final Fantasy adventure style scrolling. We can still walk off screen a little bit. Zelda scrolling begins much earlier. No problem, this just needs a bunch of tweaks. I'm gonna put in some numbers in here. I'm gonna change the threshold at which we are starting to scroll. And these are numbers that I figured out by gut feeling. These aren't things that I calculated. And yes, because of our janky if statements, we have to repeat those numbers twice. Why do you keep bringing this up? I'm feeling bullied right now. Now this will work, but now PP is off screen. We need to adjust the movement function, and specifically we need to adjust the movement of the players so they're moving onto the new map. And this is a bit confusing because technically we are already moving the player. They're moving with the map, remember? They just need to move less with the map. They need to lag behind the map so they're still on the screen when the scrolling is finished. Time for some quick back of the napkin math. We want PP to take a full 16 pixel step so they fully enter onto the new screen. The scroll takes 32 frames, so we need to be moving at half a pixel per frame. So we need to take the velocity of the map and we need to divide it by 8 to get to a half. But then the player sprite is actually already moving at the velocity of the map, so we actually need to subtract 1/8 from the current movement speed. So it's basically this, but you can simplify this even further simply by just multiplying it by 0.875. We're going to save this, we're going to run this, and look at that. Oh yeah, we're emerging onto the new screen just like in Zelda. Now, even though this is biblically accurate Link's Awakening scrolling, there's some things I don't quite like about it. I don't like how Pipi is kind of like virtual insanitying onto the new screen, how it just slides on there. That doesn't feel quite right. So something we can do here is while we're moving the map, we can simply keep animating the player, and that makes them move their little feetsies while they're scrolling onto the new screen. And this feels just a little bit more natural to me. This doesn't feel like there's a PNG scrolling across the screen. This feels as if the character is actually walking. This is not how Link's Awakening works, but this is actually reminiscent of how the original NES Zelda works. So let's just do it like this. And this is where we get to an area where it's all about taste. I generally prefer the Final Fantasy adventure type of scrolling, because here in the Zelda type scrolling, by triggering the scrolling a little bit earlier, we're kind of constricting the amount of available space that you can move around in. Especially on the lower resolution of Pico-8, this makes the screen feel just a little bit claustrophobic. And also this opens up the door for a nasty bug. If we manage to build our level in a way that puts like an obstacle right at the edge of the map, which is something that can happen very easily, right? If we accidentally have something like this, people will gingerly walk onto the new obstacle and get stuck there. And yeah, you can write some extra code to prevent this from happening. And you probably also want to avoid something like this anyway, but the Final Fantasy Adventure solution just is generally less brittle like that. So there we have it. How big of a map can we have right now? What does it look like to have 1/8 of Link's Awakening? I went ahead and filled the entire map with screens reminiscent of Link's Awakening just to find out. And I have to say I really like doing something like this by hand, because it gives you a really great insight into all those genius tricks that the original developers of Link's Awakening did to get the most out of the tile map. For example, one of the most iconic features of all Zelda games are these big bubbly trees. And I love how you can put down standalone trees, but with just 2 additional tiles, you can put them down in this kind of like staggered overlapping arrangement that looks very organic, kind of like a dense forest. You can also see how in this tile map just a lot of tiles are dedicated to drawing cliffs. There is a comprehensive construction set here with all sorts of curves and intersections. This seems like overkill, but you get a lot of mileage out of them because those cliffs do an incredible job at creating depth. With those cliffs you can create all sorts of valleys, elevated pathways and plateaus. They make a 2D game look almost 3D. Something I talked about last time around is how I love that there's those grass tiles. There's a little construction kit to create those grass patches. The actual grass tile is just a flat green tile. It's the edges and the decorations that make these flat green tiles read as actual grass without seeming repetitive or visually noisy. It's also worth mentioning that this is also where the color version differs from the original Game Boy version. In the original Game Boy version, the grass is a lot simpler and also more repetitive. They keep generally the grass pretty much white, and they allow the player's imagination to fill in the green color. Smart and efficient, but in a different way. There's so many things that I just love. A lot of those tiles can be used in multiple ways. For example, this tile map has some tiles for the facades of the houses, and for the roofs you can simply reuse the edges of the cliffs. And these donut-shaped obstacles, well, these are the edges of the cliffs as well. And this cave entrance here can be reused for many different types of entrances. It can be even combined together with the tree to make like a tree house. And you see how the original tile map that I started out with had these special tiles to draw the owl statues. But it's kind of strange because it's just the top half, whereas the bottom half of it? Well, it turns out the bottom half of the owl statue is also made out of cliff tiles. Many modders trying to edit the owl sprites for graphics mods found out the hard way. I can just thoroughly recommend spending some time with a tile set like this. There are so many valuable lessons for our own games to learn here. We all develop games under some sort of limitation, and quite often overcoming those limitations isn't just down to technical skills, it's also down to creative decision making. And when you manage to tackle the problem from multiple angles at the same time, you can make something that is impossible seem effortless. And this game is a good example of that. So yes, this is what I came up with. This is what it looks like when you use the entire Pico-8 map for a Zelda style map. And sure, it's just 1/8 of Link's Awakening, but it feels substantial on its own. I do feel like you could have quite an adventure in this world. Except, of course, that's not nearly all that we need for a real Zelda game, right? After all, a Zelda game isn't just an overworld, there's also like dungeons, and there's like indoor areas. And we haven't even talked about NPCs, right? Look, since we filled the entire map, our sprite sheet is used up with some gibberish. Yeah. I haven't talked about this yet, but yeah, it's true. In Pico-8, half of the sprite sheet actually uses the same memory as half of the map. So if you fill the map with stuff, you just don't get to use half of the sprite sheet. Oops! And sure, we could like put the enemies on here instead, but then we would have an even smaller map. Ooh. So yeah, even though this superficially looks like Zelda, we aren't even close, and we already ran out of space. In such dire times, there's one last thing we can do. There's one ace that we can pull from our sleeve. I hate to do it, but we have to go. Multi-carto drifting. That's right, one of the features of Pico-8 is that you can spread the data that you need for your game across multiple cards, across multiple files. Now, there's at least 2 different ways of doing this, but today we're gonna use just the reload way. Yes, there's this function called reload, and this allows you to load in the memory of a different card into the current card. So we can simply load the map and the sprite sheet from a different card into our current card. Let me show you what I mean. I created a brand new card, an empty card, that is just for the indoor areas. There's no code in here at all. It's just a different sprite sheet with some tiles that we can use to create indoor areas. This is just placeholder, this is not optimized at all. And then we have just a map of with 2 screens, one with like a room from a house and one with like a room from a cave. And again, I saved this as indoor.p8. Now I'm going to go back to the Zelda 2 version of our game. We have our big map already copied in here. It's full of stuff. Let us now set it up so that this house here that we have in the south, that this house leads to the different map that we have in indoor.p8. First, I'm gonna remember the coordinates of this doorway. You can see at the bottom of the screen, it says 1022. That's the coordinates of the doorway that leads to the house, measured in tiles. Next, in the move player function, after we finish each step and we return back to the idle mode, we check our current position against those 2 values. If we are on the spot 1022, we need to add the map scroll to our current position so we get our position on the actual big map. And we also have to divide it by 8 because this is a pixel coordinate and we need to get the tile coordinates. A tile is 8 pixels in size. And so if we're on the right position, we just use the reload function to load in the data from the indoor P8 file. And those are the special numbers that we need to plug in here to copy the entire map and the entire sprite sheet into our current card. And finally, we need to change the position of the player and the scroll. The scroll is reset to 0 and the player position is set at the doorway of the room. We're gonna save this, we're gonna run, and as you can see, when we walk into the doorway, bam! We are on a different map. Just like that. We just exceeded the limitations of a single Pico-8 map. Now I want you to pay attention to a little bit what happens exactly when we enter the door, where you see that there is a bit of a break and there is a small loading animation in the top left corner. This is Pico-8 indicating to us that there is multi-carting going on in the background. And because there is this little delay, it prevents us from overusing this feature. But I think for doorways like this works really, really well. So now that this works, the next step is just to set up a system to manage all sorts of different portals. You can probably imagine that a real Zelda game would have tons of portals, passages, and doorways and such. We don't want to hard code each and every one of those. We want to set up a list of warps, and we also probably want to keep track of which map is currently being loaded right now. So here's what I set up in our init function. I'm saving the map, the name of the current map in the map name variable. And then we just have a list of warps that connect one map at a certain location to a different location on a different map. And then we can just delete this old stuff in here and we can make a universal warping function like this. So after we take a step, we just loop through a list of warps. For every entry in this list, we just take those that match the current map. We check if we stepped on the exact tile that should warp us to a different map. And if we do, we load that different map, and then we set the player position and the scroll values to the destination. And yeah, this last bit here, this has some dense math. This could be maybe a little bit confusing. Let me unpack this. So the first two lines calculate the position at which the player sprite should appear in pixels. The problem that we're trying to solve here is that the warp coordinates are measured in tiles, but also there is somewhere on the map, it's not necessarily where it will appear on the screen after the scrolling has happened. This is why the first thing we do is a so-called, difficult word, modulo 16. Each screen is 16 tiles wide and 16 tiles tall. So we just divide by 16 and just take the remainder. Whatever the scrolling will be, we just interested in the position of the destination tile after all of the scrolling has happened, after we removed all of the scrolling. And then again, because each tile is 8 pixels tall and 8 pixels wide, we just need to take the result, which is the coordinates in tiles, and we have to multiply it with pixels to get the coordinates in pixels. Now next up, these two lines just calculate how much the map has to scroll to show you the destination. And again, we just take the coordinates of the destination, and this time around we divide it by 16. And in fact, this is kind of like a special division, the backslash division here, that divides and floors. So if there's any fractional values, we discard them. We just want to have whole integers. We just interested how many screens we need to scroll to get to the destination. I need to divide it by 16 because again, each screen is 16 tiles tall and wide. And then afterwards, when we counted how many screens we have to scroll, we need to then multiply it by 128 because again, we need the scroll value in pixels and each screen is 128 pixels wide and tall. So yes, this is a bit of a dense math, but this is how you get from map coordinates to the player position on the screen in pixels and to the scroll value in pixels. And there you have it. So now we can walk up to this house, enter the house, go to a different map, and we can also exit this map and be back to our original map. And look, with this system in place, we can easily add just 2 lines to add a whole different warp to a different place. So these numbers will also make it so that the cave to the west, this one, will teleport you to the second room on our indoor map. Like so. Hey, we can now also enter the cave. Isn't that nice? And we can even exit it as well. Yeah! So there you have it. With the power of multi-carting, we can break out of the limitations of Pico-8's map system. We can create all those rich indoor areas that a Zelda game needs. We can possibly create huge dungeons, and also, if you think about it, we can also create a bigger overworld map. You would just need to have to split the overworld into different carts, and then at the edge of each map you would just simply warp to the next one. And this would even possibly allow you to have different areas with different tile sets. And how you would integrate those teleporting points into the actual map, that's up to you. You can mask them so they look seamless. For example, you could have like caves that lead you to different areas, or you could have like gate houses the way you have them in Pokemon Gen 1. But also there's plenty of examples of real Game Boy games that simply teleport you off the edge of one map to the edge of the other map. There's a lot of places in Final Fantasy Adventure, also known as Mystic Quest, where it works exactly like that. Also, I need to point out that this is not the only way to break out of Pico-8's map limitations. It's just one that works without any additional tools. Plenty of people in the Pico-8 community have created their own systems and workarounds to make bigger maps possible. Just take a look at Jade Lombax's Picomap or Pencilor's Big Map Editor. Just as 2 prominent examples. If you know any more, post them in the comment section. However you want to create your own Zelda-like game, one thing's for certain. You need to plan ahead and design with the limitations in mind. Just like the creators of Link's Awakening designed their entire world structure around the bespoke limitations of their tile management system, so do you need to do your own planning around Pico-8's multi-carding or whatever other system you end up using. You can't just start blindly building your map and expect to figure things out as you go. And this is perhaps the biggest hidden assumption under the innocuous question of how do I scroll the screen? And so this is it for today. All that is left for me to do is to give a huge thank you and a shout out to all the supporters that make these videos possible. It's time for another round of shout outs to new supporters, including On Coffee, Glenn Cage, T-Type, McClure, Viv, David Gallo. We have a huge influx on YouTube memberships: Moloch Z, NNSFaka2292, Sam Garrett, Nexalam, JDJC3D, Marcos Posada, Svenspron, Angelo CSS Boy, Das Lenny, Buraga Hardy, T.Y. Hayes, Mark Screft, Kane the Guy, Gable Pennyshot, We the Squeamish, No More Mr. Nice Try, Hi, I'm Viv, Kokai Lashlo, Walking Out the Door, Paulin Hopaulin, Ashley the Citizen, Fair Weather Bar, Andrea D'Amicio, Anilip, Zenzo Merlumia, Wylantar, Kevin Thompson, Show Me Treaty, and Cohen Joss. And on Patreon we have Brett C and Mark Price. Also huge shout out to one of donations on Coffee by Lichen Corpse and Arnold. Thank you so much for your support. I really appreciate it. Now, of course, we aren't done with Zelda yet. We aren't nearly done. There's still more things to discuss. You can let me know down in the comment section about the subjects you are the most interested in next. Something I was interested in is doing maybe a deep dive into like sword stuff, you know, sword play and melee combat and stuff like that. But I'm open to all sorts of things. Let me know in the comment section. This is it for today. I've been Christian. See you next time around, guys. Bye bye.